is our sum and difference identities. Okay, as we talk about these sum and difference identities, okay, we have three identities to add to our list up here, and basically they are ways to find the sine, cosine, or tangent when we have two pieces that we know information about. So, for instance, just to mention, our first example we're going to do here in a moment is cosine of 15 degrees. Notice without a calculator. Do you know anything about cosine of 15 degrees according to our reference chart or anything like that? 15 degrees isn't a number that we've dealt with, is it? Okay, so with that in mind, we don't always want to use the calculator. So this gives us a way to find the value of cosine of 15. So you'll notice here, okay, if it's a sine and you have two pieces, x plus or minus y, then it's going to be sine of x, cosine of y, plus or minus cosine of x, sine of y. So it's once you know the x and y, you're filling it into this identity. And it'll make sense once I take you through it. I will point out that this is a plus or minus sign here, and this is a plus or minus sign here. That's just saying that if it's a plus in the first part, it's a plus in the answer. If it's a minus in the first part, it's a minus in the answer. Okay? With cosine, similar setup, just different order of events here. So cosine of x plus or minus y is cosine x, cosine y. Notice that's a minus plus sign, sine x, sine y. So this is saying that if you have cosine of x plus or minus y, minus plus means we're going to use the opposite sign. So if it's a plus over here in the beginning in the parentheses, we're going to use a minus when we're finding the answer. Or vice versa. If it's a minus here, we're going to use a plus. Then we have a tangent. Tangent looks very different, but tangent of x plus or minus y, you have this fraction. It's plus or minus on the top, minus plus on the bottom. So again, pay attention to those signs. When you see plus or minus, we're going to use the same sign. When we see minus plus, we're going to flip that sign. Okay, now, those are the identities. They're going to make more sense as we work our way through them and practice using them. So in example 1, they ask us to find the exact value of cosine of 15 degrees without using a calculator. So exact value. I'm looking for fractions, square roots, things like what's in our reference chart. I'm not looking for the decimal. I'm not looking for what the calculator gives me. Okay, because yes, I could get this on the calculator, but that's not what I'm looking for. Exact value. So, with that in mind, we're going to turn this, we're going to use our cosine identity here, and we're going to turn it into two numbers that either add or subtract to be 15 degrees. Now, I don't want to pick just any two numbers that add or subtract to be 15 degrees. I want to pick two numbers that we know something about that add or subtract to be 15 degrees. My hint is over there on the sideboard. Are there numbers that we know something about that add or subtract to be 15 degrees?
45, 30.
Okay, 45 minus 30 is 15, yes? Okay, so what we can do here is we can take this cosine of 15 degrees and we can rewrite it as the cosine of 45 degrees minus 30 degrees. Actually, I think I'm going to scoot that over just a smidge because I feel like I'm going to run out of room if I'm not careful here. So cosine of 45 degrees minus 30 degrees. Now, to be honest, that's the one we probably mostly see. Did anyone see the other option? Technically, there's another option there too. 60 minus 45 is also 15 degrees, isn't it? Okay. Now, here's the deal. We have changed cosine of 15 degrees into cosine of 45 minus 30 degrees. Basically, we're going to go in and we're going to fill in this identity here, where 45 is going to go in place of the x value, and 30 is going to go in place of the y value. So we're going to write this out. Instead of using x's and y's, though, we're going to use 45 degrees and 30 degrees. So, start off with cosine x, cosine y. So that's going to be cosine of 45 degrees. Cosine y is cosine of 30 degrees. Do I want to add or subtract here? We're going to add. This is cosine. Notice here it was plus or minus, but over here it's minus plus. So that tells you to use the opposite sign. Since we had minus, we're now going to use plus. So plus, and now we're doing sine x, sine y. So sine of x, which is sine of 45 degrees, sine of y, which is sine of 30 degrees. Okay, so we've rewritten this identity. Our job now is to use what we know to come up with a number answer here. So we're trying to get this out of sine and cosine, come up with a number answer. What do we know about the cosine of 45 degrees? Cosine of 45 degrees is what according to our chart? No. Pi over 4 is just another name for 45 degrees. What's the cosine of 45 degrees?
Square root of 2 over 2.
Square root of 2 over 2 is what I'm looking for. Times, what's the cosine of 30 degrees?
Square root of 3 over 2.
Square root of 3 over 2. Everyone see where these are coming from? Plus sine of 45 degrees is square root of 2 over 2 times sine of 30, which is 1/2. Okay, we're going to clean this up and we're done. Multiply, what is square root of 2 over 2 times square root of 3 over 2? Square root of 6 over what? No, 4. Remember, multiplying fractions, just multiply top times top, bottom times bottom. So square root of 2 times square root of 3. Remember, as long as they're the same type of root, you can multiply them. Square root of 6. 2 times 2 is 4. Plus, what about square root of 2 over 2 times 1 over 2? Square root of 2 over 4. We're going to go one more step and put this together. How can we put this together? They have a common denominator, yes. So what is square root of 6 over 4 plus square root of 2 over 4? They have the common denominator, so you get to put them together. But we can't add these, so square root of 6 plus square root of 2 stays as is, all over 4. Okay? And that's how you're going to leave your answer. That is an exact answer. It's not a rounded answer, it's an exact answer. It's in terms of fractions and square roots. Okay? If you took your calculator, and I said you didn't need calculators because you don't, but if you took your calculator in degree mode and did the cosine of 15 degrees, you would get a decimal. If you took your calculator and figured out what square root of 6 plus square root of 2 all divided by 4 is, you would get a decimal. Guess what? Those decimals would match. Okay? So that's kind of your proof that you've done something right if you want to, if you're hesitant. Okay? Questions here? This is just an example of how we use the identity. It's pretty easy identity to use once you understand them. I think the first 10 problems in homework are doing stuff like this. Now, when we get done with notes, I only have one example here, and I really should put a second example here because this example was done with degrees, yes? Well, probably about half of your homework problems are going to be in degrees. The other half are going to be in radians. And no, I never teach that I want you to just, let's just switch it to degrees. So I'll make sure before you guys leave here to do a homework example with you that is in radians, so you know how to deal with the radians. Okay? And it's not that they're bad, but just making sure we know how to deal with them. Okay? Okay, in the meantime, let's move down to example 2. They ask us to write each of the following expressions as the sine or cosine, I'm going to throw in or tangent, of an angle. So I basically want to take these expressions and condense them based on whatever they are and say sine of something, cosine of something, or tangent of something. Okay? So as you look at A, sine of 22 degrees, cosine of 13 degrees, plus cosine of 22 degrees, sine of 13 degrees. What do you notice here? What's that look like?
The top one.
The top one is in it looks like sine. Does it have the form? Because if it's the form of sine, it's supposed to be what? Sine of x, cosine of y, plus cosine of x, sine of y. Does that fit? Yeah. Okay, that fits right there. And so this is the sine of what? It's supposed to be the sine of x plus or minus y, right? So what's x? X is going to end up being the 22 degrees. What's y? 13 degrees. And am I adding or subtracting these two? Because it's the sine identity, the add subtract sign here is the same as the add subtract sign here. Okay, because the sine identity keeps the adding subtracting sign the same. And go one more step to clean it up. What is 22 plus 13? So this is going to be the sine of 35 degrees. Okay. Easy enough. The second half of homework, like 11 through 22, is like example 2 and 3, which are very similar to what we're doing here. So, okay, let's look at B. Cosine pi over 3, cosine pi over 4, plus sine pi over 3, sine pi over 4. Which identity does this look like? This looks like the cosine one, yes? Because the cosine one reads cosine x, cosine y, plus sine x, sine y. It's not that you have to write the x's and y's in there, but that's just helping me to show you what my x and y are going to be. Okay, so we said this was a cosine identity because it fits the form. So it's going to be cosine of x plus or minus y, right? X being pi over 3, y being pi over 4. Are we going to add or subtract? Subtract. Okay. Remember, if you go back up and look here, guys, cosine, it's plus minus here, minus plus here. So that's just saying your sign changes. It's going to be the opposite. Okay? So with that in mind, you don't get to stop here. What has to be true to subtract pi over 3 minus pi over 4? Common denominator? So yeah, we have to do a little bit of fraction work here. What's the common denominator between 3 and 4? 12. Pi over 3 becomes how many twelfths? 3 times 4 is 12, so 4 times pi is 4 pi. Minus pi over 4 is how many twelfths? 3 pi over 12. Go one more step. Cosine of 4 pi over 12 minus 3 pi over 12 is going to be what? Yeah, cosine of pi over 12. Okay. Okay. What about C? Sine x, sine 2x minus cosine x, cosine 2x. What? Okay. It's a flipped version of cosine. Because cosine is supposed to be cosine x, cosine y, and then sine x, sine y. So this is a flipped version, yes? So one of the things I'm going to recommend is that we flip this. Now, what's the catch here? Cosine x, cosine 2x, and then sine x, sine 2x. So if I flip the order, this is more the appropriate order, right? Cosine x, cosine 2x, sine x, sine 2x. Now, if this is a plus sign in the middle, it'd be no big deal. You flip a plus, it doesn't matter. Officially, if I flip this, now I'm not going to leave this on here, but what is this? This is a minus cosine cosine and a plus sine sine. Do we have that in our identity? We don't have that in our identity, do we? So we have to adjust this a little bit because I don't have an identity for a negative cosine cosine plus sine sine. So how do I get rid of that negative out front? Legitimately, that is.
Take it out.
What do you mean take it out?
Factor it out.
Did you say factor? Yeah. We're going to factor that negative out. The other suggestion I often hear is multiply by a negative, but I can't multiply by a negative because it's not an equation. I don't have two sides of the equation to multiply. So I need something where it's still going to be the equivalent value. So I'm going to factor a negative out. If I factor the negative out, the cosine cosine term becomes positive. What about the sine sine term? It was positive, so it's going to become negative or minus. So we have the negative of cosine x, cosine 2x minus sine x, sine 2x. Okay, it just means that negative is just going to carry along. Can you identify your x and y? Cosine x, cosine 2x means x is basically x and y is 2x. Okay, so let's set this up. I'm going to have the negative out front. We said this is the cosine identity. Cosine of my x and y are x and 2x. Okay, what happens here? Cosine of x and 2x, add or subtract. Since this is a minus sign right here, this is going to be an add right there. Clean it up. What do we end up with? Did I hear the beginning part? Negative cosine of 3x. Okay, the negative just carries along. Okay. Questions on that one? We just had to work with that one a little bit to make it look right, to make it work. Okay, what about D? Is D fairly obvious? D is which identity? Tangent. What are my x and y values? 22 and 23. So we're going to set this up as tangent. So it's tangent x plus tangent y over 1 minus tangent x tangent y. So this is going to be tangent of 22 degrees and 23 degrees. Shall we add or subtract in there? Add. With the tangent identity, you're going to do the same of whatever's on top. The denominator is the opposite sign. Okay? Clean it up. What is tangent of 22 plus 23? Tangent of what? 45 degrees. Okay? Especially if we wanted to argue, we could go another step farther. And what is the tangent of 45? But they officially just wanted us to write these as sine, cosine, or I'm going to say tangent expressions. So. Okay. Are you seeing a little bit how to use these identities? Okay. In honesty, we use them more like example 1 most often. That's where you're going to see the use throughout pre-calc or calc or something like that. But this is helping us become familiar with them. Okay. Example 3. It's asking us to simplify each of the following. Okay. We're going to do something similar. So sine of x plus pi. How do I write this out? Follow your identity with the idea that we have x and y. How's the sine identity work? Starts with what? Sine of x. Then what? Cosine of y, which in this case is pi. Are we going to add or subtract? This is a sine identity, so you keep that middle sign the same. And then second part is cosine x. And then sine of y, which is pi. Okay. Don't stop here. Okay. Now, sine of x. X is a variable. So sine of x is going to stay sine of x. Cosine of pi. Cosine of pi. See some people looking at unit circles and whatnot in their charts. Those are the places to look. What about the cosine of pi? -1. Here's your visual, folks. We have 0, pi over 2, pi, and 3 pi over 2, yes? We're being asked about the cosine of pi. What's the ordered pair at pi? You go left 1, up or down 0. What's the order in an ordered pair? The order in an ordered pair is cosine sine. So what do we know here? The cosine of pi is -1. Is that coming back to you? Okay. So far we have sine of x times -1 plus cosine of x stays cosine of x. I can't do anything with a variable. What about sine of pi? Sine of pi is 0. Okay. Clean it up. Sine of x times -1 plus cosine of x times 0. What would you give as a final answer? Negative sine of x. Because sine of x times -1, so sine of x times a negative is just going to be negative sine of x. Cosine x times 0, anything times 0 is 0. So we end up with negative sine of x. Okay? So these simplify down a little bit more because one of them has a number, one of them has a variable. We can simplify it down at least a little bit. Okay. B should be similar. Cosine of x plus 3 pi over 2. So we have a new x value and a new y value. Okay, how's our cosine identity work? We're going to start off with what? Cosine x times cosine of y. So that becomes cosine x times cosine of 3 pi over 2, plus or minus. Okay, it's cosine, so we're going to use the opposite sign, so minus. And now in the second part, we're going to do sine of x and sine of y, so sine of 3 pi over 2. Okay, similar to what you did last time. Clean up what you can. Cosine x is cosine x. What about cosine of 3 pi over 2? Cosine of 3 pi over 2 is 0. So cosine x times 0 minus sine x times, what is sine of 3 pi over 2? Negative 1. What's this clean up to be? Yeah. Cosine x times 0 is gone. That's 0. A negative sine of x times a negative 1 is going to turn around and become a positive sine of x. Okay. And lastly, tangent. Okay. Identify your new x and y. And again, not that you have to write that down, but can sometimes be helpful. Okay, how does tangent work? This one we set up as a fraction. On top is tangent x plus or minus tangent y. So that means we're going to be doing tangent of x plus or minus tangent of pi over 4. Am I adding or subtracting here? Okay. The top of the fraction is the same sign as the original problem. It's plus minus just like the original problem. Denominator is 1 minus plus tangent x tangent y. What sign do I use down here? We use the opposite sign, so we use plus. I made a mistake on top. I don't know if anyone caught it or not. It's going to be tangent x tangent y, so I'm going to say tangent theta tangent pi over 4. What did I do on top? I stuck with x instead of theta, so let me go back and make that a theta. You're listening to what I said or watching what I wrote. Sorry. Okay, let's see. What can we clean up? Tangent of theta. Theta is just a variable, so that's tangent of theta. Minus, what's tangent of pi over 4? Tangent of pi over 4 is 1 according to our chart. You don't even have to look at the end of the circle, just go to the chart. So tangent of theta minus 1 over 1 plus tangent of theta times tangent of pi over 4. What is tangent of pi over 4 again? 1. I do have this cleaned up just a smidge. I left it as tangent of theta minus 1 on top over, now the denominator. Tangent theta times 1 is tangent theta. We have 1 plus tangent theta then, or I think in my notes I have it written as tangent theta plus 1. It's not going to matter which way, whether you write it as 1 plus tangent theta or tangent theta plus 1. Either way will work. Okay? Okay. Your homework is page 418, 1 through 22. Okay? You have about 10 minutes. I want you to at least do one problem, because I'm going to at least have you do one problem with me to make sure we are good to go. 1 through 10 is a lot like example 1. 11 through 22 are like examples 2 and 3. Okay? it's the 1 through 10 radian examples that I want to make sure we know how to deal with the radians. So if you will, pull your book out, get your paper set up, and I think it was number 6 that I did together in class this morning.
I look at my notebook. Sorry.
Yeah. So 1, 2, 3, 4 are degrees. You should be able to figure out degrees, I think. Ask me questions if you have. But starting at 5 through 10 are radians. And we didn't do any radian examples, did we? In terms of this type. 5 is a cosine example, so I think I did 6 this morning because it's a sine example. So 6 is sine of 7 pi over 12, right? I told you I wanted you to stay in radians, yes? I don't want you switching to degrees. I want you to be able to work in both. Do you know which 2 radians are going to add up to be 7 pi over 12? Some of you can honestly say yes, you'll be able to figure it out. Some of you are going to look at me and say, I'm not sure what you're talking about. Here's the deal. Do any of our denominators, 12ths? No. So here's my suggestion of what you do. I suggest we take our basic 3, which are pi over 6, pi over 4, and pi over 3. And if you look, I don't know how many of you have looked at the homework, but problems 6, 7, 8, 9, and 10, they all have denominators of what? 12, yes? So here's my suggestion, is let's turn these all into denominators of 12, because once you have them all in denominators of 12, the section becomes easier. What do you know about pi over 6? It's going to be 2 twelfths, so 2 pi over 12, right? 6 times 2 is 12, so pi times 2 is 2 pi. What about pi over 4? 4 times 3 is 12, so 3 times pi is 3 pi. And what about pi over 3? 4 pi over 12, right? 3 times 4 is 12. Pi times 4 is 4 pi. Now, with that in mind, now can you give me 2 angles that we know something about that add up to be 7 pi over 12? Okay, that's where I'm going to recommend you have this list beside you. Okay, because this list of angles is going to help. So I can take 7 pi over 12 and split it into what 2 angles? Yeah, I'm going to write it as 3 pi over 12 and 4 pi over 12 for the moment. But I totally agree with what you're saying. This is a true statement, yes? Sine of 7 pi over 12 is equivalent to sine of 3 pi over 12 plus 4 pi over 12. Now, we don't think of those angles as 3 pi over 12 and 4 pi over 12, though. 3 pi over 12 reduces to pi over 4. 4 pi over 12 reduces to pi over 3. So yes, you could have started with just pi over 4 plus pi over 3 once you make that realization. I'm just trying to show the connection. Do you know what to do from here? How's that sign identity work? Sine of x. So sine of pi over 4. Cosine of y. So cosine of pi over 3. With the sign identity, do I use the same sign or change the sign? Same sign. So plus. Now we're going to do cosine of x. So cosine of pi over 4. Sine of y. So sine of pi over 3. This is just like example 1 now. And in fact, the answer is going to be really familiar. What is the sine of pi over 4? Square root of 2 over 2, according to my chart. What is the cosine of pi over 3? Square root of 3 over 2. Plus, what's the cosine of pi over 4? Square root of 2 over 2. I just realized that was backwards. Because what's the sine of pi over 3? Square root of 3 over 2. I didn't catch the mistake. What's the mistake? Cosine of pi over 3 is supposed to be what? 1/2. Clean it up. Well, it's not the exact same answer as example 1. Is it very, very similar? Actually, this is the exact same one. It does end up being the exact same, I forgot. Square root of 2 over 4 plus square root of 6 over 4. Put it together as one fraction and we have square root of 2 plus square root of 6 all over 4. Okay? So, with that in mind, that will help you with 1 through 10. Now, one other thing real quick before I let Mr. Houndstein have a moment. You have majority of 1 through 10. Knowing these angles will help. There's 1 or 2 examples where you need to think about your second quadrant angles. When I talk about second quadrant angles, 2 pi over 3, 3 pi over 4, and 5 pi over 6. In other words, I can't remember what they are, but you're trying to get a number like 10 pi over 12 or something like that, or 11 pi over 12. Well, I can't get 2 of my first quadrant angles to add to 11 twelfths, can I? But if we transfer these to 12ths, you can here. And we'll talk about this more tomorrow. But 2/3 would be 8 twelfths. What about 3/4? The 9 twelfths, and 5/6 would be the 10 twelfths. So I'm giving you that hint there. Keep in mind second quadrant angles will come into play. Okay? Tomorrow, we'll talk homework questions. And I do expect some homework questions, but hopefully you'll be on a good start now. Okay?